In this video, I'll show how to make a model of the methane molecule in Sketchup. First, let's go to Wikipedia and see what they're showing. The methane molecule has a central carbon atom surrounded by 4 hydrogen atoms. Okay, that tells us that what we need is a carbon atom represented by a black ball, then a hydrogen atom represented by a white ball, and then we need a single atomic bond, which we'll put over here, and then we're going to connect these together. We'll go to View Phase Style X-ray, and then connect the center points together, and then we will make this into a group. Okay, the first bond is simple enough. We can attach that because we know that there's one bond that goes up vertically. So we will make this go up vertically. And we could use the rotate tool, except we can't find a surface that's vertical, so it really can't align properly. So let's use the Move Tools rotate tool, and now we've got that right. Notice, in case you've never seen that before, you just hover over the plus sign, and then you click and drag. Okay, now we'll go over here, and we will attach the bond to the carbon atom, like so. Okay, that's one bond. We have 3 more to go. So what's the angle between this and the next bond? Let's go back here to the Wikipedia article, and here we see a diagram, and it shows that the angle is 109.5 degrees, and this is the same between all of the bonds, so they only show it once, 109.5 degrees. So what we have to do is we have to make a copy of this, and then we have to twist the copy down 109.5 degrees. So we can go like that. That gets us down to 90, of course. And then if you look in the lower right hand corner, we're going to enter 19.5, and that gives us a total angular separation of 109.5 degrees. Okay, but what about the other 2 bonds that stick out this way? Well, we're going to use some projective geometry to figure out how we need to turn those. And I made a little diagram here. Let's imagine that there's a little stick figure guy, and he's looking up at the bottom of the methane molecule. Okay, and you can see that he's looking up because his head is tilted back and his hat has fallen off. And this is what he sees. He sees that these bonds are sticking out like so, and the angle of separation is the same in each case. And we can do a little math here, and we realize that if the angle of separation is the same over 360 degrees, then A is going to equal 120 degrees. So what we need to do is make copies of this bond and rotate them 120 degrees. So let's make a copy. And we can use the traditional rotate tool because we're rotating in the default horizontal plane. Oops. And we're going to go 120 degrees. That's a little cluttered, but we'll just move it over there. And then we'll make a copy of this one. And then we will go 120 degrees more. Like so. Okay. And then we just have to attach these. takes care of that one. Then we'll go over here and we will bring this down. Got to be careful about attaching them because there are so many stray points in there when we're tilted at an angle like that. We will bring this over like so and zoom in for precision work. Locate the center point there and the center point there. And then we'll go out. And now let's select all these items so that we can make a group. And now we have a methane group. And we will turn off X-ray. Click somewhere else so we get rid of the box. And there is our model of a methane molecule.